Let us see the question number 25th. Question number 25th is about to avoid what? To avoid the difficulty with strapping. To avoid the difficulty with strapping at high frequency. To avoid the difficulty with strapping at high frequency, the type of what? The type of cavity structure used in the magnetron. Yes, the type of cavity structure used in the magnetron to avoid the strapping at high frequency. Strapping at high frequency. So that is the option first is whole and slot, second is slot only, then C is van, and D is rising sun. D is rising sun. Okay, so now see, he is asking about to avoid the difficulty. To avoid difficulty. To avoid difficulty. To avoid difficulty with strapping to avoid difficulty with strapping. Yes, with strapping at high frequency, at strapping at high frequency, the type of structure used in the magnetron, the type of structure used in magnetron is used in the magnetron is what? That is rising sun. Okay, so that is rising sun cavity. Rising sun cavity. Okay, we use this type of structure, rising sun cavity, that is used. Okay, that is used in to avoid the stepping, to avoid the difficulty with stepping at high frequency of the structure. Okay, high frequency at high. Okay, with the stepping at high frequency, the type high frequency the type of structure is used in the magnetron is, that is rising sun cavity. So option number D is correct. Okay, option number D is correct. So now we are going to explain this, okay, in one manner. Okay, about what magnetron, what is strapping. First of all, the option is D. Okay, so now see here, to avoid the difficulty with strapping, first of all we will see where we are using what this strapping in magnetron. Okay, so this is what my magnetron. What? Magnetron. Okay, so multi cavity magnetron you can say also. So the magnetron is what? It's a high frequency. It's a high frequency generation oscillation. Okay, so magnetron is used. Actually, magnetron is a vacuum tube device. Okay, so it's a vacuum tube device. In order to generate high frequency, in order to generate high frequency in order to generate high frequency of oscillation. Okay, so the magnetron is actually a vacuum tube device. Okay, so which is used in order to generate, okay, which is used to generate high frequency device, in order to generate high frequency of oscillation. Okay, actually it gives the power to the RF signal, radio frequency signal. Okay, we want to energize the radio frequency signal. That is the main purpose here of magnetron. And this magnetron is used in what? Magnetron is used in magnetron is used in radar. Magnetron is used in radar and microwave oven. Okay, so these are what application where we are using the magnetron, okay, in most of the time in radar and microwave oven. So its main purpose is to increase the frequency of oscillations in the RF signal, okay, so that we can increase the power of RF signal. So the magnetron is a multi-cavity magnetron, okay. It has the cavity like 8 cavity, 16 cavity, like even number of cavity, okay, in magnetron. And its working principle of magnetron is based on the LC oscillation. Yes, LC oscillation. If you see the magnetron, actually, what is the purpose of magnetron that we have seen? That actually here what we want to energize the RF signal, radio frequency signal. Okay, in order to energize the radio frequency signal, we use the magnetron, that is a vacuum tube device, in order to generate the high frequency of oscillation, so that so that what RF signal will get the energy. Okay, it will get energized. Then how to do this? We will do by this its working principle, which is totally based on the LC oscillation. Okay, which is totally based on the LC oscillation. How it work? Actually, what we are doing here. This is my magnetron. Let us say here LC oscillation means, if as we know very well, this is what our 10 circuit. Yes, if you see this LC circuit, LC circuit. This is my inductance capacitance. What is happening here? If you see what is happening here, there nothing happening. Just here exchange of energy. Okay, so there exchange of energy takes place between this LC, between this inductor and capacitor. Okay, inductor and capacitor. So there is a energy exchange between the LC, between these two element, that is inductor and capacitor. Okay, so they never store the energy, but they will deliver its energy one and another. Like inductor will transfer its energy to capacitor, and capacitor will transfer its energy to the inductor. Means there is two and four two and fro oscillations. Okay, is happening here. Okay, oscillation is happening. Then after that, with that oscillation means what? That is what voltage and current oscillation. This is a actually here happening what oscillation of VI, voltage and current oscillation. So that is what power. Now power for this, what we will do? Now we will connect this to an antenna. Okay, through like this is our antenna. Through this antenna, we can radiate this power. Okay, through antenna in the free space as electromagnetic wave. Okay, in electromagnetic wave, this LC oscillation. LC oscillation is nothing but it's a power oscillate. Power is oscillating. Okay, as we know very well here, current is changing. That is what voltage across the capacitor. If you see, it is a rate of change of current. Here, if you see here, current through this capacitor, it is a rate of change of voltage. Voltage is changing, and here current is changing. But this is what VI oscillation. Okay, so both voltage and current are changing. Means ultimately the power is oscillating. Power is changing. Okay, power is oscillating. Now this oscillating power we want to transmit it in the free space through the electron, through what an antenna, through an antenna, okay, into the free space in the form of electromagnetic wave. So like this magnetron is there. Magnetron just work like this. Okay, so just working principle of this magnetron is based on this LC oscillation only. Now in magnetron, what is there? If you see the magnetron here, magnetron, that is a magnetron. In magnetron has what? Magnetron has one cathode. Okay, so this is at center. Actually, it's I'm just drawing its upper, its top portion. Okay, actually it is a cylindrical form. Okay, I'm not designing it in three dimensional, only single dimension. Its top view. Okay, so that is over cathode. This is what cathode. Okay, through which we are emitting what? Electron by hitting, by we are hitting what? Just like this is over one anode, cathode. Okay, so here we are generating what? Electron through this we are generating electron. Okay, this is like this This is what cathode. So cathode. So then there is a anode. Anode in the form of cavity, with cavity. Okay. So let us say here there is a 8 cavity. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these are cavity. These are cavity. Okay. So now see here why we are why we are designing this cavity, because we want what. So these are anode. Just see, after that we will understand why we are designing this cavity. So this is what, this is anode. These are what, anode. Okay. So these are anode. Okay. So this is anode. Okay. These all are anode. These are cavity. This is cathode. Now cathode work is what, to generate the electron. Okay. It will emit the electron. Okay. So now these are anode. Now we want, because this, if you see these are working as a plate. Okay. So these two adjacent plate, it is working as a capacitor. Okay. When it will generate the electron will go there, and here charge will get induced. This is, let us say, this side positive charge, this side negative charge. Okay. This side negative charge, this side positive, negative, positive, negative. In this plate, like positive, positive, here negative, 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 negative. Like here negative, 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 here positive, positive, positive. These are what, these are actually capacitor. Yes, capacitor. Now this, and here, and if you see this will act like a inductor across this. Okay. We are connecting what this inductor. Okay. Inductor. So this is what, inductor and capacitor. It's like a inductor and capacitor. Exactly, it's like a inductor and capacitor. Okay. So now these are the plate, and its upper portion is acting like an inductor, and these adjacent plate are acting like as a capacitor, and its upper portion, if you see, this is what, inductor. Here also capacitor. Here inductor. Okay. Here inductor. Here capacitor. Like negative, 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 positive, positive, positive. This is capacitor, and this is inductor. Yes, everywhere inductor, capacitor means there is a oscillation. Yes, there is a oscillation. So there is oscillation. Then after that, after that there is a transfer of energy. Yes, transfer of energy between what, between between the AC signal, between the AC signal and what, AC signal, energy of this AC signal and the energy of electron. Okay. So energy of electron and energy of electron and energy of AC signal, we are here energy is what, transferring with each other. Okay. With each other, like here capacitor, inductor, there is also energy transfer. Okay. Energy transformation is taking place here between inductor and capacitor. Like here, if you see the anode and cathode, how it will how there is a energy transformation occurring. So let us see. So how it is. This is what cathode. If you see this cathode is what, actually it is a, like, it's like a hitting rod. Okay. It is like a rod. So we are hitting it like around 1000 degrees Celsius. Okay. At 1000 degrees Celsius it will generate what, electron. Once it will generate electron, okay, it will emit this electron. Okay. Initially assume that here magnetic field is 0. Okay. Once this electron will travel toward, okay, electron will move toward this, from cathode to anode. Okay. In straight direction, direct, in straight direction, it will move direct in straight direction, because there is a so many electron, means electron here. Then these electron will move directly in straight path toward what, toward anode. These are anode. These all are anode. Okay. So this electron will travel toward anode. Okay. From this cathode. So this is anode. Okay. All are this anode. Okay. These are anode. Okay. So here, when magnetic field is 0, then it will travel just in straight path toward anode. Now, and there is no magnetic field. Now we are entering through one portion magnetic field. We are applying what, RF signals. Okay. We are applying here RF signal. Just apply RF signal from one portion of this cavity. Okay. One portion of cavity. Now here is a generate. Here magnetic field will get formed. Okay, so here magnetic field will form here, like if you see here positive to negative side here, like this. Here you see this is cathode, this is cathode. Okay, so here if you see here, this here now once we will enter, what RF signal from this portion of cavity, then there is a generation of, you see, let us say this is positive negative positive negative positive negative positive. Okay, so there here the mode is what, pi mode. At pi mode it will generate, at pi mode, this is my pi mode. Okay, it will generate highest power in this mode, in this pi mode. Okay, every adjacent cavity is out of phase by 180 degree. Okay, 180 degree. So now see here there is a what, once we will apply this RF signal, then here then here magnetic field will get induced. Okay, from positive to negative side, from positive to negative, positive to negative. Okay, positive to negative, positive to negative, like this, positive to negative. This is from positive to negative. Okay, so like this, everywhere, everywhere, positive to negative, always from positive to negative, 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 like here also positive to negative. This is what, my magnetic field, these are magnetic field, magnetic field, these are magnetic field. Just take the sign, always from positive to negative. Direction of magnetic field is from positive to negative. Direction of magnetic field from positive to negative, positive to negative. Okay, so like that, like that. Here magnetic field is zero, magnetic field is zero. Here magnetic field is zero. Okay, so now here magnetic field is not zero. Here if you see magnetic field here is zero. That's why electron is directly moving toward anode. Now here magnetic field is not zero. Now magnetic field is what, greater than zero. Now here when this electron will move toward anode. Okay, when this electron move toward anode, then it will not move in straight path, because its movement will somewhat deviated by what, magnetic field. Okay, here magnetic field will apply some force to this electron, direction of this movement, and the moment of electron will get deviated by small amount. Okay, it will get deviated as we increase, what, as we will, this is what, this much. Okay, this is this much, this electron has deviated like this. Okay, if magnetic field is not there, it will directly move like this. Okay, so now magnetic field is there, now it will move like this. Okay, its direction will get deviated by small amount, as v is greater than zero. As we increase more, as we increase the magnetic field, then it will get deviated more. Okay, okay, its direction will get deviated more. Now we will see here, when, what we will see here, see, when this electron will move toward this. Okay, so this anode, now this electron will move toward this. Now this magnetic field will accelerate, this magnetic field, now it will accelerate this electron. Okay, so like this, here you see, so this is my electron is moving like this. Okay, toward this, what, anode. Let us say there is anode. Okay, there is this cavity. I am just, for understanding purpose, I am designing one cavity. Okay, so one cavity like this is my cavity. Okay, here is my cathode, this is my anode. Okay, so this is like positive negative. Okay, this is second cavity. Now see here, the electron is generated from this, and it will move toward this anode. Okay, this anode has magnetic field from where to where, positive to negative. And now next one has opposite. Okay, so let us see in proper way. So this is my second cavity. Okay, so this is my first cavity, and this is my cathode, and electron is moving from this toward this anode. Okay, these are anode. Now, if you see here, this here it has magnetic field. Okay, magnetic field, magnetic field here. This is positive. Let us say negative, positive, negative. This is positive, negative. Okay, so positive, negative. This is positive. This is negative. Okay, so this is negative, positive. This is positive, negative. Now see here the direction is from positive to negative this side, the direction is this side. Okay, so now let us say here the electron is moving this this side. Okay, electron is moving toward this cavity, toward this anode. Now this magnetic field will what, this magnetic field from positive to negative. Okay, positive to negative of this. Okay, across this what cavity, it will what, it will increase, it will what, accelerate this electron. This magnetic field will accelerate this electron. Okay, this electron once accelerate, once this magnetic field accelerates this electron, then velocity of electron will increase. Velocity of electron increase means kinetic energy of electron increase. Kinetic energy of electron increase means what? Kinetic energy increase means what? Means what? Electron energy increase. Electron energy increase means where this energy is coming. This energy is coming actually from what? Magnetic field. Yes, magnetic field. So this is what coming from RF signal. Means which signal? RF signal. Means this AC signal. Now this AC signal energy is totally what, maximum energy is transferring what, toward this electron. So electron get energized. Okay, because the electron energy increasing, from where this energy is coming? This energy is coming from RF signal. Now RF signal, instead of what, instead of amplifying the RF signal, we are what, we are just attenuating this RF signal. Okay, RF signal will get attenuated instead of amplifying. Why? Because it is accelerating the electron. Once the electron will get accelerate, means acceleration is increasing, then velocity of electron will get increase. Velocity of electron increase means kinetic energy of electron will get increase. Therefore, energy of electron will get increase. So total this energy can neither be created nor be destroyed, but it can transfer from one form to another form. So from where this energy is coming? This energy is coming from where? This energy is coming from RF signal. Okay, so therefore instead of what, amplifying the RF signal, it will get attenuated. Okay, so this signal is getting attenuated instead of what? Instead of amplifying. Where this energy is going? This energy is going to electron. Okay, so now in this cavity, okay, so this due to this what, magnetic field across this cavity. Okay, it will what, it will accelerate this electron. Now if you see this adjacent cavity, here the magnetic field is there, this is in opposite direction. Now this magnetic field will retard this electron. Yes, this magnetic field will retard this electron, and this electron will come toward back toward what, cathode. Okay, so now this magnetic field, it will accelerate this electron, but adjacent cavity, the magnetic field which is across this adjacent cavity will retard this electron. Will retard this electron. Once the electron will get retarded, then what happens? Once the electron will get retarded, then its energy will get decreases. Energy will get decreases. Yes, energy of electron will get decrease. Why? Because the magnetic field which is just existing at the adjacent of this cavity, it will what, it will retard this electron. Once electron is retarding means what, its energy is decreasing. Its energy decreasing, where this energy will go? This energy will go to what? This energy will go to RF signal. What? Radio frequency signal. So therefore this radio frequency signal will get increase. Yes, the radio frequency signal will get increase because these magnetic fields are retarding this electron. Yes, therefore the electron energy will get reduced. Okay, because electron velocity decreasing means decreasing means what? Kinetic energy decreasing. Kinetic energy decreasing means this, where this energy is going, this energy is going to RF signal. Okay, so in this way, in this way RF signal will get amplified. Okay, so the main point is what here. Main point we have to focus here. What during the acceleration of electron by the magnetic field, that time the velocity of electron will get increased. Yes, once the velocity of electron increase means what its kinetic energy will get increase. Once kinetic energy increase means its energy will get increase. So therefore, once the energy of electron will get increased, where this energy is actually coming? This energy is coming from RF signal, radio frequency signal. So therefore, radio frequency signal will get attenuated. We do not want this. Okay, our main our main ultimate goal is what to increase the energy. Okay, to increase, because we want to energize RF signal, radio frequency signal. For that, what we need, we need to retard this electron. We need to retard this electron. Once the electron is retarding means what, its energy is decreasing, because its velocity of electron will get decrease. Okay, will decrease, and this energy will get transferred to RF signal. So therefore, in this way, we are amplifying this RF signal, radio frequency signal. Means we are increasing the frequency of oscillation. Once we are increasing the frequency of oscillation, therefore, in this way, we are able to what? We are able to increase the power of RF signal. Okay. So this is the actual process, actual working of this magnetron, whose work is totally based on what? LC oscillation. LC oscillation is happening like this only. Okay, so there is what energy exchange is happening between the inductor and capacitor. They do not store the energy. Means what? Exchange means what? Here is nothing but a VI oscillation. Voltage and current are oscillating. Okay, so voltage current oscillation is nothing but actually there is a power oscillation. Okay, now this power oscillation we want transmit it. Okay, we want transmit it through a space, through the antenna, with the help of antenna in the form of electromagnetic wave. Okay, so this is the main purpose of magnetron, because the magnetron we use it at high power device. Okay, so because where we want high power, there always we should prefer what? Magnetron. Okay, so magnetron is are used in what? Radar. Okay, so which will make this radar much more efficient, and it is also used in microwave oven. Okay, so microwave oven. Now coming about what? Strapping. Now about strapping. See what happens in strapping. Why we need strapping? Now see why we need strapping. Actually, strapping concept. See here, strapping. Why we need this strapping? Strapping. See, strapping. Why we need? Actually, what is happening? This cathode that we have designed just now, we have designed. This is what cathode. I have shown you just front portion of what? This magnetron. Okay, if I will design this like this, is actually cylindrical shape. Okay, so here we are applying some DC voltage. Okay, across this we are applying DC voltage across this cathode. Okay, so this is over DC supply. Okay, so this DC supply has what? Potential energy. What is this potential energy? If you see, QV naught is equal to half of mv square, where v is nothing but what? V is equal to 2q v naught divided by what? 2q v naught divided by m. This is what? Velocity of electron. This is my voltage. Okay, so this is what? This is DC power. This is what? DC voltage. DC voltage means here potential energy. If you see, potential energy is equal to kinetic energy, half of mv square. Okay, so now we want what? We want to convert this energy which is present in the DC signal to what? DC signal to the electron. Okay, so we want to transfer whole of this what? Potential energy to what? Electron. So now see here electron. So this is what? This is cathode. Now this cathode, we are hitting this cathode at 1000 degrees Celsius. Okay, so once you heat up this at 1000 degrees Celsius, then electron will get transmitted. Electron will get emitted from this cathode. Okay, now these electron will go to what? these electron will go toward anode. Okay, with these electron will move toward anode. So now, actually, what is happening? Sometimes there is a some disturbance in what DC power DC supply. Okay, so sometimes there is a there is a disturbance in DC supply. So due to this disturbance, what happened? The mode of cavity. Yes, mode of cavity will get what due to disturbance. Okay, so there is a disturbance. What is there? Disturbance. So due to this disturbance, the mode of what the mode of magnetron, mode of cavity, mode of multiple cavity magnetron will get changed. Okay, will get changed because we have what type of mode? We have pi mode. We have pi mode. Okay, we have pi mode. Then due to this disturbance in the DC power supply, this mode will get changed and it may get changed to 3 pi by 4, which is again existing. Okay, which also exists, but this is pi mode. Pi mode is what? Pi mode is the highest mode where we can achieve the maximum power. Okay, so pi mode is the mode where we can achieve the maximum power. Maximum power means maximum energy of electron is transferring into what? RF signal. Okay, in radio frequency signal in this pi mode. Okay, but due to some DC power disturbance or some external noise, so due to this the mode will get shifted. But mode will get shifted to other mode, and in that case what is happening? The power will get decreased. Okay, power get decreasing. So therefore we want to maintain this pi mode. We want to what? Maintain this pi mode. To maintain the pi mode, what we use is strapping. What do you mean by strapping? Strapping is nothing but, if you see here, this is my cathode and this is my anode. These are my anode. Okay, one, two, three, 4, 5, 6. Let us say this 7 and 8. Okay, so these are my cavity. Okay, these are my cavity, multiple cavity magnetron. These are my anode. These are my anode. Okay, so if you see here, strapping is nothing but we are just connecting this alternate cavity through wire. Okay, so through electric wires. So let us connect this to this. Okay, so then after that you just connect alternate through alternate. We are connecting this through wire. Okay, so this is connect this these cavity are connecting to this. Okay, so we are connecting this to alternate. Okay, so we are connecting what? We are connecting the cavity, adjacent cavity, alternate through what? Through wire. Okay, alternatively this cavity will connecting, this cavity is connecting to this cavity. Okay, by leaving one cavity, then this is connecting to this. Okay, just alternate. There is a alternate connection. Okay, so strapping is nothing but alternate connections of cavity through wire. Okay, in order to what? In order to maintain pi mode. So pi mode. So in pi mode, so that we are able to achieve the highest power. But the problem is coming in case of strapping. What type of problem is there? The problem during the strapping that we face is what? That is nothing but inter-electrode capacitance effect is there. Because if you see at high frequency, as you see, inter-electrode capacitance is there. These are wiring. Okay, so that we are using. So there is what? Capacitance effect. These are parasitic capacitance that will come into the picture at high frequency. Because if you see the frequency f, if you see this capacitance, impedance is equal to 1 by j omega 2 pi fc. Okay, 2 pi fc. If you see fc at high frequency, what is happening? At high frequency, these parasitic capacitance will come into the picture. Okay, once the frequency is increased, then what happen? This impedance will get increases. Yes, once frequency increase means what? Something by increase means this impedance will get decreases. This impedance decrease. If frequency is so high, means in the order of gigahertz, because we are using the frequency in magnetron in the order of gigahertz, zero point 0.6 to 30 gigahertz. So therefore, here at that frequency, if you see the impedance of this capacitive impedance is zero means it is short. It is shorting. Yes, it is short circuit. Short circuit means what? Some signal or some current will go through this path. Means there is a what? Leakage. Power leakage is there at high frequency. this type of problem is occurring at high frequency. This is first problem about what this is parasitic capacitance that comes into the picture at high frequency, or at high frequency if we are using this strapping, yes, this strapping through the wire. Another problem is what? Another problem is radiation. Yes, radiation will occur at high frequency. High frequency. Radiation loss will occur at high frequency, because as we know very well, at high frequency what happens? At high frequency, the wavelength will get decreased. Yes, as we know very well, the relation lambda is equal to c by f. Lambda is equal to c by f. Now, at high frequency, what is happening? This wavelength will get reduced. That point will come. That certain at certain point. Okay, so at certain point, the point will come where this wavelength, with this wavelength and the length of the component will get comparable to each other, and that time this element will start radiating, and this conductor whatever, so this conductor will get start radiating at very high frequency, because in high frequency both wavelength and the length of the element will come in comparison. Okay, both have some comparison wavelength, comparison length. Okay, so therefore here the length of what length of element is comparable to the wavelength at high frequency. Therefore, this element or this conductor will start radiating. So this is what radiation. Okay, radiation losses will occur at high frequency. And second is that there is a parasitic capacitance which will come into the picture at high frequency. So therefore, to avoid this strapping, to avoid this strapping, what we do here to avoid this strapping, instead of what instead of taking equal size of cavity, we will take one small cavity and one large cavity, one small cavity, one large cavity, one small cavity and one large cavity. Okay, one small cavity, one large cavity, and this is large cavity, this is small cavity. Okay, so this is large cavity, this is small cavity. Yes, so we are using this type of cavity. Okay, it is looking like a sun. Yes, it's exactly looking like sun, because we have taken some of the cavity is in large size, and some of the cavity means alternate cavity we are taking, we are taking in different size. Okay, so therefore if we see here the automatically automatically we are maintaining pi mod. We are able to maintain pi mod without using strip, without using strapping. Yes, without using strapping we are able to what we are able to maintain the pi mod. Okay, maintain the pi mod. This is what this is the benefit, this is the advantages of this sunrise cavity. Okay, so sunrise cavity we are using in magnetron at high frequency. Okay, at high frequency. So therefore, to avoid the strapping, why we use strapping? We are using the strapping in order to maintain the pi mode, but in the strapping there is coming some difficulties, with some disadvantages there in strapping that we have seen already. That is nothing but at high frequency the parasitic capacitance that will come into the picture, and the other is there is a radiation losses at the high frequency. Okay, so in order to eliminate, okay, so in order to eliminate this type of losses, we are going what we are going to sunrise cavity. Okay, sunrise cavity, we can eliminate all these problems through sunrise cavity, because there is no need of strapping. Okay, so directly we can maintain the pi mode, just taking the different size of what cavity, alternate cavity. Okay, so that is the solution for this, what for the for in magnetron. To avoid strapping at high frequency, we always go for rising sun cavity. Okay, rising sun cavity, because because it has different cavity, adjacent cavity is different, and we are able to maintain the pi mode. Okay, so that's all for this solution about the stepping. Yes, so that's all.